3.2, synthetic division. So this is when we have basically a function divided by pretty much like the equation of a line. And it's just the way that we go about doing that. So we have x cubed plus 7x squared plus 13x plus 6 divided by x plus 2. So if there's was anything in front of x, or there were any other x terms or anything like that, we could not use synthetic division. Synthetic only works in scenarios that look like this. So what we do is we take the opposite sign of this number that's here. So in this case, it's going to be a -2. And we put it in a box. And then we use the coefficients of the number or of the terms on the top. If there's any term missing, then we have to put in a 0 for it, or it's going to give us the wrong answer. So we've got 1, 7, 13, and 6. So the first thing we do is we bring down the 1. So whatever the first number is always just gets brought down immediately. Then we multiply this times whatever's in the box. So 1 times -2 is -2. And then we add these terms, or obviously subtract if they're subtracting. So 7 minus 2 is 5. Then 5 times -2 is -10. 13 minus 10 is 3. 3 times -2 is -6. 6 minus 6 is 0. So that one worked out to where there was nothing left over. If there's a number over here, all that means is it's a remainder. But it doesn't ask us to actually write anything beyond that. So that's all you have to do. Or, well, actually it does. So then, more so just for reference for you, so you see it for the future, because coming sections will need this. This originally was an x cubed term, and so on and so forth going down. When we're done, we write this as x squared. So whatever this term started as, it loses like 1x as we go. So if we then ran synthetic again on it, it would continue to lose x's until we got down to nothing left. But so x squared plus 5x plus 3. If there was a remainder, then we would actually we would have something else done with it, but this one doesn't have one, so nothing to do for that one. So if we took this function and we divided it by this is what we would get, is what that tells us. And no remainder. Let's see. 14. X to the 6th minus 3x to the 4th plus 2x cubed minus 6x squared minus 5x plus 3. And this is going to be divided by x plus 2. So I put the opposite sign of this number in the box, so that's going to be a -2. Then I'm going to use the coefficients of this. But in this case, the x to the 5th term is missing. Okay, so if there's anything missing, we have to put in a 0. So x to the 6th is 1. There's no x to the 5th, so I put a 0. And then I just go on across, nothing else is missing. So -3, 2, -6, -5, 3. Because if a term is missing, we have to put in a 0. Otherwise, your answer isn't going to come out to be right at the end. You'll get like a weird remainder if you don't have the 0. And if there's a problem in the pre-cal book, I think it is, where they have something like, it's like x to the 12th plus x minus 6. So there's like a whole bunch of terms missing, and that problem has like, you know, however many zeros that ends up being in there. Because otherwise it causes the answer to like be wrong. So it's kind of like a placeholder, which is what helps with that. So we bring down the 1 times -2, -2, add the 0, still -2, times -2 is 4, -3 is 1, times -2 is -2, plus 2 is 0, times -2 is 0, minus 6 is -6, times -2 is positive 12, minus 5 is 7, 7 times -2 is -14, plus 3 is -11. So then our remainder is this -11. So when I go to write my like conclusion statement of what this would be equal to, this was an x to the 6th term, so we change it, and now this is an x to the 5th term. So we have x to the 5th minus 2x to the 4th plus x cubed. Since there's a 0 here, I don't need to write the x squared term. I just need to know that I'm skipping x squared when I go to the next thing. So minus 6x plus 7. Now, when we get to the remainder, whatever number this is, we put that sign here. And then we write the number, so 11, over whatever we divided by, which was x plus 2. So that's how it looks if we actually have a remainder with it. Let's see, one more of this kind. 16, -11 x to the 4th minus 2x cubed minus 8x squared minus 4 divided by x plus 1. So what number am I putting in my top left box? -1. And then I'm going across. So I have a 4th term, a cubed term, a squared term, but I'm missing an x term. So when I get to that x term, I need to have a 0x put in there. So if, let's say you struggle with remembering to put in that 0 term, because that happens a lot, I would say when you go through and you see if any terms are missing, go ahead and write this in as whatever term is missing, so when you go to write them here, you don't forget to write it. because I'll be honest, even sometimes I forget to write in the zeros when I'm doing problems. So that just kind of helps you to like remember, hey, I need to put these in. So negative 11, then negative 2, negative 8. Now I'm at my 0, and then negative 4. So then bring down our negative 11 times negative 1 would be positive 11 minus 2 is 9 times negative 1 is negative 9 minus 8, that would be a negative 17 times negative 1, that would be a positive 17 plus 0, so it's just 17 times negative 1 is negative 17, and then minus 4 would be negative 21. So that's my remainder. So my first term was an x to the 4th term originally, so now it's going to be an x cubed term. So I'm going to have negative 11x cubed plus 9x squared minus 17x plus 17. And then we do minus 21 over this x plus 1. Any questions on those so far? All right. So the next thing that we do with this, they say use synthetic division to divide f of x by x minus k. So basically, that's what was happening here. The general form is x minus k, but it can also be x plus k. For the given value of k, then express it f of x in the form f of x equals, so I'm gonna write down what it's supposed to be written in the form of. So f of x is equal to x minus k times q of x plus r. So basically it's just a slightly different way of writing what we just did. It pretty much ends up being the same thing, except for we're also writing in what we divided by, basically. So just for reference, looking back at number 16, this number that goes in this box right here is k. So if the problem said k is equal to negative 1, we write that in exactly. But then we change the sign when we put it back up here, which is the x minus k general form, but it can be x plus k, obviously. So the way these problems are going to be given to you, it's going to be f of x is equal to 2x cubed plus 3x squared minus 16x plus 10, and k is equal to negative 4. So a few things we're still looking for if a term is missing. In this case, I'm not missing any terms, so I'm good to go. The other thing really quick, just to point out when I was saying stuff about the missing term, if the constant term at the end was missing, we would also need to put a 0 on at the end. That's probably the most common one people forget. They'll replace the x's that are missing, but they'll forget about the constant term at the end. And they'll be like, why is my answer wrong? Because you didn't have the 0 at the end. But anyways, that was just a random side note. So now they give it to us a little differently. So they give it to us as k is equal to negative 4. That means this number gets plugged in exactly. So if they tell you what k is, we plug it in exactly. If it's given to you the other way, we have to change the sign. So we have -4 going in the box. Then same thing, copy down the numbers. So 2, 3, -16, and 10. And then this process is going to be the same. It's just the way we write our final answer is going to be a little different. So we bring down the 2 times -4 is -8, plus 3 is -5, times -4 is 20, minus 16 is 4, times -4 is -16, plus 10, so that would be -6. So I still have a remainder of -6. Now, what we did before is we would have just written this was a cube term, so this is now a squared term, which is still going to be part of our answer, but there's another part to it now as well. So, like I said before, when we have it written like this up here, this is x minus k, okay, quote unquote. What happens is if we set this equal to 0, we would get x equals -1. -1 was k. Okay, so that's basically, we're going to do the inverse here. So they said k is -4. We're going to move that over. Okay, so basically we're going to have that x equals -4. We move this over. X plus 4 is equal to 0. This would be the factor that we actually divided by. So in a sense, basically we went from what they gave us back to what it would have looked like in the previous problems. And we basically rewrote it how we did the first 3 problems that we did. So now I'm going to use this x plus 4. That's going to be this first x minus k part. It's just our sign is different. So x plus 4 is going to be the first part. Now, the q of x part is this part that we got from here. So q of x is going to be this 2x squared minus 5x plus 4. So I'll just note that's the q of x part. Then I have a negative remainder again, so this is going to be minus 6 divided by x plus 4. And that would be how they're looking for your final answer for these ones. So just the format is a little different. We could have done the first problems the exact same way. They just have you doing them a little differently. In preparation for future sections that are coming down the pipeline. Let's see. Let's look at 30. F of x equals 2x to the 4th plus x cubed minus 15x squared plus 3x, and k is -3. So I'm going to go through and look and see if anything is missing. I've got x to the 4th, x cubed, x squared, x, but I'm missing my constant term. So I'm going to write in a plus 0 so that I don't forget to put that in when I do my synthetic division. So they gave us k, that means we plug in exactly. So -3 in the box. And then copy numbers down. So 2, 1, -15, 3, and 0. So then bring down our 2. Times negative 3 is negative 6. Plus 1 is negative 5. Times negative 3 is positive 15. Minus 15. So that's 0. Times negative 3 is 0. Bring down the 3. Times negative 3 is negative 9. Plus 0 is negative 9. So that's my remainder. Apparently negative remainders are popular today. So I'm going to do it just like I did 26. So over here, this is x or k equals negative 3. I like to think about it as x equals negative 3 just for the purpose of setting it up. So I move the negative 3 over. So I have x plus 3 equals 0. That means this is the factor that I'm using. So I'll have x plus 3 times, so this was an x to the 4th term, now x cubed. So I've got 2x cubed minus 5x squared. The next term is a 0, so I'm going to skip it. Then plus 3. And then the remainder part, so minus 9 over x plus 3. All right, this next one I'm going to have you try on your own just for a minute and see how we do with it and see where we're at, and then I'll go over it with you. So it'll be just like this one. So 32 f of x is equal to negative 5x to the 4th plus x cubed plus 2x squared plus 3x plus 1, and k is equal to 1. And just because we haven't had one that ended up this way, if it had a positive remainder, this sign would just be a plus here instead of a minus. So it's not like it's always minus. It's whatever the sign is here. So just FYI. All right, so take a minute and try that one. do we have an answer? Or anybody want to share their answer with the class?
X minus 1 into 5 minus x cubed minus 4x squared plus x.
Did you have a remainder? Put mine up. I might have something wrong. Do you see what you did? Oh, okay. I was like, I might be wrong. It's very possible. So let me go back and look. So we put in 1. And then this is what we got with synthetic. Remainder of 2. So x minus 1 ended up being the factor because we had basically x equals 1. Oh, come back. And then move it over. So x minus 1. So we had x minus 1 times negative 5x cubed minus 4x squared minus 2x plus 1. And then plus 2 divided by x minus 1 for our remainder. Any questions on that one? Or on these? All right, the next thing is probably the easiest thing in this section. It is the remainder theorem. And so the remainder theorem basically says that if you, to reword what you had in your notes, basically if you plug in whatever k value is given to you into f of x, so you have f of k, whatever number you get when you solve that is your remainder number. It doesn't tell you anything else other than the remainder, but if it tells you that much, that's good. So 34 f of x is equal to x squared minus 4x minus 5, and k is equal to 5. And also, just something to point out, like if a term is missing in this, it doesn't matter. We don't need to worry about it. We're just plugging it in wherever there's an x. So remainder theorem says I do f of k, which in this case is f of 5. So anywhere I see an x, I'm putting a 5. So this is kind of like going back to the composite functions that we did where we were plugging in numbers. It's kind of like that. So we've got 5 squared minus 4 times 5 minus 5. So that's 25 minus 20 minus 5, which in this case ends up being 0. So my remainder in this situation would have been 0. So that means that basically x minus 5 would have been a perfect factor of that, which you probably can factor this on your own without needing to know that, but that would show that. 38 f of x is equal to 2x cubed minus 3x squared minus 5x plus 4, and k is equal to 2. So I've got f of 2 this time. So anywhere I see an x, I'm putting a 2. So I have 2 times 2 cubed minus 3 times 2 squared minus 5 times 2 plus 4. So 2 cubed is 8 times another 2 is 16. 2 squared is 4 times the negative 3 would be negative 12. Negative 5 times 2 is negative 10. And then plus 4. So that ends up being negative 2. So my remainder for this one would have been negative 2. And if you're ever not sure if you did it right, you can always check it by the synthetic method of plugging that k value in and running synthetic on it, because the answer that you get in the box at the bottom right should be the same as this. So if you're ever not sure, you can check it that way, and vice versa if you don't think you did something right. All right, the last thing for this section is to use synthetic to decide whether the given number k is a zero of the polynomial function. If it is not, give the value of f of k. So basically, all that means is when we run synthetic, if we get a 0 in the box on the bottom right-hand side so that there's no remainder, it tells us it's a factor. And again, this is leading into the future sections that we'll do where we have to be deciding if something's a factor or not. And if we get a remainder, we'll know that it's not. If we get 0, then we know that it is. And so the part where it says if it's not, give the value of f of k, that just means tell what the remainder is. So 50 f of x is equal to x cubed plus 2x squared minus x plus 6. And k is negative 3. So I'm back to synthetic now. So I just plug in k exactly. So that's negative 3. Still looking if any terms are missing, I got to put the 0. In this case, no terms are missing, so I'm just writing them in. So 1, 2, negative 1, 6. So bring down the 1. Times negative 3 is negative 3. Plus 2, negative 1. Times negative 3 is positive 3. Minus 1 is 2. Times negative 3 is negative 6. Plus 6 is 0. So because I got a 0 here, that tells me that this is a factor. Okay, and the factor specifically would be x plus 3, because we would move this over. And so that would be the factor, which it doesn't ask you for that, but it just simply asks you if it is a factor. But again, trying to give you a little preview of the sections that are coming. Let's see, 52. F of x is equal to 2x cubed plus 9x squared minus 16x plus 12, and k is equal to 1. So no terms are missing. They already gave me k, so I just plug it in. So 1, then I've got 2, 9, negative 16, and 12. Bring down the 2. Times 1 is 2. Plus 9 is 11. Times 1 is 11. 11 minus 16 is negative 5. times 1 is -5. Plus 12, that would be 7. So my remainder in this case is 7. So I would say that this is not a factor because I ended up getting a remainder. And I would say that the remainder is 7, so you can just write r equals 7 or whatever the value is for your particular problem for that. All right, any questions about any of this at the moment? All right, then problems are 7, 13, 27, 31, 35, 43, 49, and 51. And it is Wednesday, so we don't have a lot of time left today. But I'll give you some time tomorrow to work on this at the beginning because we can't really go on to the next section without you having done this. So we'll have time tomorrow to work on this and then go on to the next section after that. But anyways, it's not due till Friday, all that to say.